Hi everyone, my name is Louisa and today I'm going to be teaching you about Kirchhoff's loop rule, which is also known as Kirchhoff's voltage law or Kirchhoff's second law. So Kirchhoff's loop rule is a tool that we can use to help us keep track of the voltage at different points in a circuit, and it's a very useful tool for figuring out voltages across resistors or things like that, and you will see how we use it in a second. Basically, what Kirchhoff's loop rule means is that when you make a complete path around a circuit, starting from the positive terminal and ending at the negative terminal of the battery, the total change in voltage should end up being the voltage of the battery. So I think the easiest way to think about it is this. You start off at the positive terminal of the battery. Your voltage at that point is voltage of the battery. Then, when you get to resistor 1, the voltage drops. And since we know Ohm's law is Ohm's law, voltage equals current times resistance. Then we're going to subtract the current at this resistor times the voltage times the resistance of that resistor. So the easiest way to think about this is to start at the positive terminal of the battery. At that point, your voltage is positive and its value is the voltage of the battery. Now you're going to walk along, and walking along the wire doesn't change the voltage at all. There's no voltage drop when you walk through a wire because we assume that it's a perfect conductor. But then when we get to this resistor, it's going to take some of that voltage to cross the resistor. So we're going to subtract the voltage of that resistor. And then we're going to keep walking and we're going to get to this one. And now we again need to use some of our voltage pushing to get across. So we're going to subtract the voltage of resistor 2. Let me make this one resistor 1 so it's a little bit clearer. Keep going, we get to here, and again we need to subtract some voltage. And we're going to subtract the voltage across resistor 3. And then by the time we get to the negative terminal, this is always going to be 0. So I did this a little bit backwards because I started with a specific example and then told you the rule. But the rule that we're actually talking about is that when you start with the voltage of the battery and you make a walk along any complete loop in a circuit, you're going to end up at the negative terminal of the battery with voltage 0. In later videos, I'm going to use that and demonstrate with some examples, and I'm also going to use some more complicated situations where we might have multiple batteries or we may have capacitors in the circuit. Those are all going to change the voltage in different ways. But once you understand this rule, it becomes a very powerful tool when you're analyzing a circuit.